Hey guys, it's Shah here at the Tech Borg, and today's video we're finding angles of an isosceles triangle. Oh, not isosceles, but my bad. I should have said right angle triangle. So I'll just put it like that. So we're gonna be finding the angles in a right angle triangle, or any specific angle at least. So here's an example of the how the diagram should look like. So this is theta, which you want to find. This is your opposite, this is your adjacent, and this is your hypotenuse, and this is your right angle triangle. And yeah, so now the question is, how do you find an angle? Well, you know there's only one way, right? It's SOHCAHTOA, which is sine equals opposite over hypotenuse, or cos equals adjacent over hypotenuse, or tan equals opposite over adjacent. So first of all, we have to give an input to the user. First we have to know, do you have the opposite slash or and adjacent? Actually no, let's ask him for sine. So that's opposite and hypotenuse. There we go. Okay, and then now if you say that's I don't know, what was graph? No, sine cos tan. I think I just called it that because you just ideally want to know which one to use, right? Sine or cos or tan, which is what we're doing here. So do you have the opposite hypotenuse, which you want to type as 1, or have adjacent and hypotenuse, which we will put as 2, or opposite and adjacent, which is your third option. And then if we put a question mark here, space holder there, okay, print, please, this is just to let these know, please type in the number that applies, please type in the number in the bracket that applies. Okay, alright, awesome. So first we've asked the user sine or cos or tan. Okay, so now if the user tells us opposite and hypotenuse, which is number 1, so if sine cos tan equals to 1, over here we have to first calculate it. So first, now this is where we have to import library. So now we have to import math, which is a library, and then you do math dot, and then you do sine. Actually no, you do first of all you actually have to do opposite over the hypotenuse. So opposite equals input, and then you get your input of opposite, which is opposite, and then that's in, actually the units don't really matter as long as it's all the same, right? So hypotenuse input hypotenuse. Good. Okay, so we've got our opposite and we've got our hypotenuse. So now we have to actually calculate opposite over hypotenuse and then do arc sine of that. Yep, so we have to do the a cos, and to do that, well, now we have to use a math library as well. So to do that, you just do, well, we call our angle x, and we say x equals to math dot a cos, which represents arc cos of opposite divide hypotenuse. Okay, so let's just save that. And maybe, I'm guessing there might be an error, because we haven't said that the input is integer or decimal or float appropriate. But let's give it a try. Let's see how it goes. So if I run this now, okay, so I pick 1. Okay, so as you can see, stop the script. Why has that happened? Maybe because I haven't put the 1 in like this, because I've defined it as a string. As you can see, that's clearly what has happened. So now if we do opposite, which is 5 over 6, it might give me an error. And yes, as I thought about, because well, let's just say we allow only integer inputs to make our life easier. What we could also do is we could also use float values, which is decimals basically. But for now, let's just keep it straightforward and just use integers. So 1, and then opposite is, I don't know, something like 5. the hypotenuse always has to be greater than the opposite, obviously. And as you know that the sine curve never goes above 1, so you won't get any values if you put inverse of sine of 1, I believe, or anything more than 1, obviously. So yeah. Oh yes, and we've calculated the value of x here, but we haven't printed out anything, so let's just do that real quick. So 1, 5, 10. As you can see, it's given me 1.047 blah blah blah. So that's the answer in radians, and if you want to convert it, you just have to do x times, and then what you have to know is that you just times it by 2 pi, which is 3.14 blah 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 blah. Or there's another way, which is math.degree x, and then it'll print out mass x in terms of degrees. So let's just do that. And I think degrees is just much better. I personally like degrees more, but at A level you seem to use radians more. Degree, I think degrees maybe. Let me just rerun this. 5, 10. As you can see, there you go. It's 60 degrees. As you know, inverse sine is 60 degrees. I don't know why. Well, you can expect a decimal answer, because technically what it's doing is it's getting it in radians and then timesing it all by 2 pi over 180. No, sorry, 180 over 2 pi. So it's producing that 0, 0, 0, 0, and then 1 in the end when it rounds it. So that's expected. Again, you can always round it to an earlier decimal place. I know you know how to do that because you probably must have seen one of my previous videos. And now we're just going to repeat the case for all of these. So to save time, I'm just going to copy and paste this here and here. Now instead of 2, I'm going to put 3. Sorry, I'm going to put 3 here, 2 here, and then put this here, then put 3 here instead of this, and then instead of opposite I'm going to have adjacent, and then instead of opposite over here I'm going to put in adjacent, and then this is cos specifically, so just, yeah, so over here you want to have opposite, and then you want to have, oh sorry, you can just leave it as OPP, my bad, and then you can just put adjacent over here, and then you have to change this as well, adjacent. Awesome. Now we have to, instead of doing opposite over adjacent hypotenuse, you have to do opposite over adjacent, and then over here we have to do it instead, we change this, no sorry, we change this to adjacent over hypotenuse. I should have just written hypotenuse as HYP. I just made it longer for myself, but that's really it, honestly. Yeah, so that's 2 adjacent and hypotenuse. Let's say it was 2 hypotenuse 4. As you know, again, arc cos of half is 60 degrees. If I just grab a calculator real quick and just check on my calculator, you can grab your calculator and do that on your. Sorry, not arc cos is 60. Cos 60 is a half indeed. Arc cos of a half is 60 degrees. As I've checked on my calculator, you can check on your calculator if you want. And that's really it, guys. So for what we've done, we imported maths. Then we've asked the user, do they have opposite and hypotenuse, or adjacent and hypotenuse, or do they have opposite and adjacent? And I've shown you a diagram of how it roughly looks like. And we've written specifically right angle triangle, so they know beforehand what it looks like. And then after that, we just literally just ask them for the input of the opposite and hypotenuse if they have that, or adjacent and hypotenuse if they have that, or opposite and adjacent if they have that. After that, it's just simple maths, importing maths. So what you've done is you calculate the arc cos of the angle, and then you convert it in degrees, as we've done over here, 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 and here. And that's really it, guys. This was partially challenged, but yeah, it's not too hard. I mean, it's very straightforward. We just use a bunch of ifs, and maybe the import math for some of you is a little new, especially that math.acos and math.degrees. But yeah, that's really it, guys. I hope you guys enjoyed this video, and like, comment, subscribe.